Okay, so now what we're going to do is in this video is we're going to do the Riemann sum definition that we did before. So we're going to use the rectangles, and so we're going to use this generic example of where we have these two functions of y, u and v, and we're going to say that, hey, let u of y and v of y be continuous functions on the closed interval from c to d now on the y-axis, such that u of y is greater than or equal to v of y, right? So u of y is greater than or equal to v of y over the entire interval for all y in that closed interval, okay? So what we're going to do is we're going to do the same thing. We're going to divide the rectangles into equal widths. And how do we do that? Well, we're going to find our delta y, right? So delta y is going to be the distance from C to D. Oops. Divided by n, however many rectangles or subintervals we want to work with, right? So this is our delta y. And then, of course, within each subinterval, so now our subintervals are going to go from y0 to, to y1, y1 to y2, etc. And so it's going to go from yi minus 1 to y sub I. And of course, this is for all I equals 1 to n, right? So however many subintervals we have. And then what we're going to do is we're picking a point in each subinterval, y star, right? So yi star in each subinterval. And then we're going to calculate, or we're going to evaluate the function. So we're going to use u of y star, yi star, and v of yi star. Okay, and this is going to give us the top and bottom of our rectangles. So notice that here, let's just take this example right here. So this here, if this is our y sub I, this would be what? This would be your u of yi star. And over here, this would be your v of yi star. And so if we put it together, right, so if we want the area of one rectangle, what's the area of the rectangle? It's the width, right? What's the width? Our delta y. Times the height of a rectangle. What's the height of a rectangle? It's going to be the top minus the bottom. So right minus left in this case. So it's going to be u, so the area of one rectangle would be, so the area of one rectangle would be u of yi star minus v of yi star, okay, times the width, which is delta y, and so this would be the representation, the expression for the area of one rectangle. And then of course we're going to sum this up over all the different rectangles. So we would get an approximation very similar to what we did before, and it would be the summation for all I equals 1 to n of u of yi star minus v of y sub I star times delta y. And then of course, this being a Riemann sum, let's take the limit. So we're going to take the limit, so then a actually equals, right, we're going to get the exact value when we take the limit as n approaches infinity. So this would be the limit as n approaches infinity of the summation from I equals 1 to n of this entire thing, right, times delta y. And of course, that becomes our integral. But now, it's just in terms of y now. So in the end, what do we get? We get the integral from c to d of u of y minus v of y dy. And that's it. And so in the next video, I will give you the next theorem, and then we'll do examples. Take care.